So yesterday we completed the one equation that is very important equation. That equation we called as the solution of damped vibration. He may ask you 10 marks question. So along with that, the 10 marks question, another three cases we are going to discuss for that. That is, or we recall this equation. What we got the equation last class means x is equal to x naught divided by 2 1 plus b divided by admit 1 plus b divided by b square minus omega square into e to the power of minus b plus b square minus omega square into t under root into t plus of x naught minus 2 into 1 minus b of b square minus omega square into e to the power of minus b and minus this minus quantity into t. This is the solution of damped equation what we got in the yesterday class. Now what we are thinking means x is a displacement and time is the variable here. So what are the values are there? X is there, x naught is there, and b is there, omega is there, and t is there. Just you observe here. Okay, so x is a displacement, x naught is there means when it is a maximum position. When it is vibrating, it is a maximum position. If it is up and down, so maximum negative side or positive side, or it is in the horizontally maximum from the mean position. This is the x naught. When it becomes a zero maximum place, it will start to turn in the another direction. Therefore x is equal to 0 1 2 in this way. So therefore there are x naught, x, these are the displacement. B and omega are the angular frequency and b is the constant. That constant is called as a damping constant. This we know that. But what are the other than these factors? It all changes only by the t or x. But one factor, that factor b square minus omega square is the factor. This can change whole equation. I mean to say that the damped vibration is based on these two values. It may change its damping condition. That damping conditions are but a critical damping, over damping, and under damping. So these discussion will give again 5 marks. So one by one we'll discuss here. Okay, one by one we'll discuss what are that means. Only is going to change here when first case b square is greater than omega square. In this term b square is greater than omega square means, so this we called as a over damping case. What is called over damping. So if you look at the picture or look at the equation, what is that? B square minus omega square is there. When b square is greater than omega square means this value will become positive or negative. See, b square is greater than omega square means definitely the whole term will become the positive term only, because the b is greater than the omega square. This means, for example, 4 square minus 2 square. Okay, this term will become positive only. So therefore this is a positive, we call it as a positive. But how to define this definition means, whenever the damping means there are the two conditions. What two conditions? But when the mass is suspended by any material or any rigid body, so this goes under two forces. One force, restoring force, and another force is the resistive force. Under the action of restoring force and resistive force, okay, the damped of this body comes to halt with a minimum time. Damps comes to halt with a minimum time. How? For example, for you take one equation or one the graphical representation. But this is the time you take, this is the displacement take. So damping means it comes down. So from higher displacement position to higher position to, it will come now like this up to here. So it not reaches the minimum time. So it not a minimum time, but it is a small time. So comparing to the another damping, this type of changing of its amplitude, okay, smaller amplitude, and comes to halt. This x is equal to 0, x is equal to 1, x is equal to, in this way is there. So position will comes down, or the amplitude like this comes to halt within a short period of time. This type of condition of vibration is called as a what we call as a over damping conditions. This is the first case. Second case, what we will write here, second case, okay, b square is equal to omega square. So where b square, the term b square minus omega square, we know when b square is equal to omega square means this term will become what, beta? So this term will become equal means the b square minus omega square is equal to 0 is there. So certain condition, certain state of vibration of the body is called a critical vibration. This is called critical vibration. Or the pictorial representation of this also same. This is the time, this is the displacement you will take. Okay, so how will change? Suddenly it will reach us to 0. The 0 of this displacement is reaches to 0, or the amplitude comes to halt. The amplitude comes to halt with a minimum time comparing to the last equation, comparing to the over. It means this is also the body under the force of restoring resistive force acted on the body comes to halt with a small time or minimum time. What minimum time is? Comparing to the last equation, what is the over damping. So this type of damping is called as a critical damping. This is the difference of both. Now, next another one, b square is greater than omega square. Okay, this is third. Here b square is greater than omega square if I write. Okay, what is the term value? What the value will become, beta? What is the value? B square by omega square means what value we will get here? So the value we will get here always, for example, this is a 4 square minus 2 square. B square is greater than, it means, sorry, b square is less than omega square term is there means b square minus omega square. How we will write, beta? For example, 2 square minus omega is, b square is greater than, the omega square is less than, no, therefore 4 square. When this you will take means 4 minus 16, what will is? It is always negative. Therefore this term you make rearrange in the positive way. How you will write? Whatever b square minus omega square is there, no, this will make they like this minus b square, omega square minus b square I will take it. Okay, or minus root taken outside, what it remains? Omega square minus b square. So minus 1 under root of 1 can be written as, what will write? That is in the imaginary equation. Imaginary equations are there, no? In the imaginary, what will write here? Minus b I can be written as minus 1. So therefore this minus 1, or we know that minus 1, okay, or I square is equal to minus 1 we can write. By using this fundamental part, what we'll write means b square minus omega square can be written as omega square minus b square, but is into I. This is equal to n. This is called degeneracy factor, because to convert this positive only we are taking. So leave it, whatever is there. How to define this? How to define this means, so definition is like that: whenever the two bodies are there, or two axis or two coordinate axis values are there, one is the time, this is the displacement. So the amplitude of this, see, the amplitude of this positive, negative, positive, negative, positive, negative comes to halt. It means the amplitude is decreasing when it is going to oscillate. It means comes to halt, but not suddenly as like the critical, as like the over damping. It is coming diminished form. Amplitude will be minimum, like. But here also vibrating is under the two separate forces only. One is resistance force and resistive force, another one is the restoring force. Under that the action of the body comes diminished with respect to time and comes to halt at the last time. This type of vibration we call as a, what we call as a under damping vibration. This is called as a under damping vibration. In this way we need to discuss. Or another one point he may ask you, what do you mean by quality factor? Means quality factor means how much under damping of this body, that is called quality factor. The body, whatever vibrating, how much under damping is there, this body is going to describe that equation by quality factor. Or you can write this quality factor in this way: the cycle, the number of cycles required for the energy falls of e to the power of 2 pi. This is called the quality factor. Or mathematically we write the quality factor can be w by 2b. So w by 2b, or 2b is equal to omega by q. Rearrange the term. You know the, but we know the degeneracy factor. Degeneracy factor, n is equal to omega square minus b square is there. Last case there. So this may change in this way, omega square minus b square can be written as, see, 2b is equal to what? Omega by q is there. B is equal to omega by 2q. So I write here omega by 2q. Omega by 2. Omega 2 square q square. Or omega square minus omega square divided by 2 is a 4 q square. This is. Or you take it omega square outside. What remains? 1 minus 1 divided by 4 q square. So this, in this way you need to write this. Or you take the equation of differential equation. What is the equation of differential formula there? You know that d square x by dt square, previous case, plus what is that? Omega. See, there is 2b, no? 2b dx by dt, last case, last class, plus of omega square by x is equal to omega square into x is equal to 0 is there. Here 2b is there according to quality factor. Quality factor, what is the 2b? 2b is equal to omega by q I substitute. Therefore d square by x dt square plus 2b is omega by q. This I will write omega by q. Okay, omega by q. So 2q can be written as, this is dx by dt plus omega square is equal to x is equal to 0. When the quality factor explanation is there, means up to here you write. Once again, quality factor means it is just you are going to determine, or you, how much under damping is there, or larger the number of cycle, larger of the quality factor. That quality factor can be written as, in the form of mathematics, that is w by 2b. 2b is the damping constant only. So rearranging the term, so applying the different values in the differential equation. Valuing the differential equation, network problem. ಯಾಕೆ ಹಿಂಗೆ?